9.4 is on trapezoids and kites. Remember, a trapezoid has one set of parallel sides, as you can see here and here, and it's also a quadrilateral. It has two other sides that will intersect with the parallel lines, but are not perpendicular. An isosceles trapezoid, by definition, means that it is a trapezoid where the non-parallel sides are congruent. I can show you that with tick marks. Those two sides are congruent, meaning they are the same length. There's also some other interesting parts about a isosceles trapezoid that we need to talk about. In an isosceles trapezoid, base angles are congruent. What this means is that remember a trapezoid has two bases. One parallel side and the other parallel side. Those are the two bases. So base angles are congruent means that here's an angle by a base and here's the other angle by a base. These angles are in fact congruent. Also, on the other base, there are two angles that are congruent. You can see here I'm putting two arcs showing that A and D are congruent, and we can write that. Angle A is congruent to angle D. Angle B is congruent to angle C. We can also talk about supplementary angles. Supplementary are two angles that add to 180 degrees. So, supplementary angles in an isosceles trapezoid are something like angle A and angle B. Those are a pair of supplementary angles. So we can say angle A is supplementary to angle B. We can also say angle D is supplementary to angle C. And one last key piece about isosceles trapezoids that we have to talk about is that they're diagonals. If we were to draw some diagonals in here, I can tell you that the diagonals are congruent. So that needs to be added. We have 3 points that we added to our definition of isosceles trapezoid. The third is the diagonals are congruent, meaning AC, line segment AC, is congruent to line segment BD. Let's take a look now at some examples now that we have these 3 points to keep in mind when looking at an isosceles trapezoid. In these examples, we're asked to find the measure of each angle. Now, we have to look and think about the rules that we just wrote down. Now, 1 and 70 have a relationship. They are supplementary. The reason why is because you have a parallel line and a parallel line. This side is like the transversal that we learned last chapter. Now, 70 and 1 are on the same side of the transversal, so 70 and 1 are same side interiors, which means that they add up to 180. So to find 1, all we need to do is take measure of angle 1 is equal to 180 minus the 70 that's already there, and we'll get the measure of angle 1. When I take 180 minus 70, I get 110 degrees. So the measure of angle 1 is equal to 110 degrees. We are also asked to find the measure of angle 2. The measure of angle 2, remember, in an isosceles trapezoid, this is one base. The two base angles are the same measure. So therefore, the measure of angle 2 is equal to 70 degrees, just like the other base angle. Let's take a look at B now. B is an isosceles trapezoid. We can see that because of the tick marks here. They show us that it is, in fact, an isosceles trapezoid. Now, we can easily find out what 2 is because 2 and 120 are same side interior angles. To find the measure of angle 2, all we need to do is take 180 minus the 120 that's already there, and that's going to give us angle 2. So the measure of angle 2 after I subtract here is 60 degrees. Now, we can easily find the measure of angle 1 because the two base angles are the same measure in an isosceles trapezoid. So therefore, the measure of angle 1 is also 60 degrees. They are both 60 degrees. This concludes our trapezoids that we're going to talk about for today. Let's take a look at kites now. A kite is a quadrilateral, meaning it has four sides with two sets of consecutive congruent sides. What that means is two sides that come right after each other. That's what consecutive means, right after the other. That's what you can see here. These two short sides, AB and BC, they are the same length, and you can see that with one tick mark. Now, AD and CD, they are consecutive sides too, and you can see with two tick marks on each, both are congruent. The last piece about kites that we need to talk about that's important is its diagonals. If I draw diagonals in here from B to D and A to C, you can see that they intersect at a perpendicular intersection. Perpendicular, all it means is that they create 90-degree angles. So let's write that down. The diagonals of a kite are perpendicular. Diagonals of a kite are perpendicular. You can even write yourself a little note. Perpendicular means 90 degrees if you want. Okay, so I lied. We have actually two pieces of information. The first piece was the diagonals. The second piece is that these two angles right here on a kite, angle A and angle C, they are always congruent if it is a true kite. So A and C, remember, those angle measures are congruent. Now that we've added some definitions about kites, let's take a look at a few examples. To find the missing angles, we have to use our definitions of kites. Angle 1 is pretty easy to find because, remember, this angle and this angle in a kite are the exact same, or congruent. So we can say that the measure of angle 1 is equal to 110 degrees. The measure of angle 2 is a little more work to get to, but it's still not that hard. Now, if we were, let's say, to draw a diagonal in here, we would cut both of these angles up here into two equal angles, meaning we would cut 80 into two angles of 40. So let's mark that. This is now 40, and this is now 40. Now, what I have here, if I draw it to the side here, I now have a triangle. All triangles add up to 180 degrees, so therefore, I know that this is still 110 and that this is 40. I can find half of 2 by subtracting from 180. When I do that, I take 180 minus 110, but I have to add 40 to it first. When I do that, I actually get 180 minus 150. And 180 minus 150 is 30 degrees. So therefore, this little angle x here is 30 degrees. So to find the other half, I have two of those 30-degree angles. So therefore, the measure of angle 2 is actually 60 degrees. In this last example, we're asked to find the missing angles. We can see that 1 and 2 are right by the diagonals. And if we use our definitions from before, we know that two diagonals of a kite, when they intersect, they are perpendicular, which means 90-degree angles. So that makes our life a lot easier. Measure of angle 1 is equal to 90 degrees, and the measure of angle 2 is equal to 90 degrees. We still have to find the measure of angle 3. Angle 3, remember down at the bottom of this kite, these two angles are split evenly by the diagonal. So really 3 can go here and it would be the same measure as the 3 where it's actually at. So what we do is take a look at this triangle, and we already know that 2 is equal to 90. So we add the 2 up and subtract from 180. The measure of angle 3 is equal to 180 minus 75 plus 90 first. Then we can figure this out. When I add those two together, I actually get 180 minus 165, and when I subtract that, I get the measure of angle 3 is equal to 15 degrees. So if I wanted to find the whole measure of angle D, we could say it was 30, but they're just asking us to find angle 3, which is 15 degrees. So my three answers are 90, 90, and 15. This concludes our lessons on trapezoids and kites. For your assignment, you can find your homework on page 473. I would like for you to do numbers 1 through 4, 9, 13 and 14, and 16. See you Monday. If you have any questions, make sure you come in Monday morning so I can help you. Thanks. Have a good weekend.